Good morning to one and all present over here. Today we have to see about the manufacturing technology. Myself, S.Manikandan, Department of Mechanical Engineering, Erode Sengunthar Engineering College. Today we have to see uh, the manufacturing technology process, which is specifically training for SC/ST students for their higher education purpose through AICTE PRERANA scheme. First question. Craters wear occurs mainly on the different options are nose part from relief face and side relief face of the cutting tool, face of the cutting tool at the short distance from the cutting edge only, cutting edge only, front face only. If anybody knows the answer, kindly discuss. Otherwise, I will tell the answer. If anybody having any idea, crater wear occurs mainly on the nose part from relief face and the side relief of the cutting tool, face of the cutting tool at the short distance from the cutting edge only or front face only. Let us we will discuss the answer. Okay, actually the crater wear occurs mainly on face of the cutting tool at a shorter distance from the cutting edge only, because when cutting action takes place, due to shearing action, chip will flow outwards, and after some time, due to self weight, it will fall again because of wearing takes place at a certain distance. That's why we decide that the face of the cutting tool at the shortest distance from the cutting edge only is the correct options, because crater wear is a only in a brittle material only. So that's why we are telling. Crater wear means the material diffuses from tool face. It creates the friction between surface and the chip. Okay, kindly note down. The option B is a correct one. Crater wear occurs mainly on the face of the cutting tool at short distance from the cutting edge only. Next one. A fixture does not guide the tool. Is it true or false? A fixture does not guide the tool. True or false? Kindly think on it. Actually, the creator does not guide the tool, isn't it? Actually, the answer is the fixture does not guide the tool. Correct one. Okay. A jig supports the tool, whereas the fixture guides the tool. Okay. A jig supports the tool, whereas fixture guides the tool. So the fixture does not guide the tool is a correct one. Okay. The jig supports the tool, whereas the fixture guides the tool. Okay. Um, where jig is used to guide and fix the workpiece, and the fixture is used in the fix the workpiece. Okay. Have anybody knows about the zigs? Actually, a zig is a type of custom made tool used to control the location or motion of another tool. That is the purpose of jigs. Whereas zigs and fixtures only hold and fix the workpiece. Okay, so the answer for this question is a fixture does not guide the tool is correct. Kindly note down the answer. We go for the next one. Gear lapping is an operation. Gear lapping is an operation for the options are after heat treatment, prior to heat treatment, for gear reconditioning. None of this. Gear lapping is an operation after heat treatment, prior to heat treatment, for gear reconditioning, none of this. Actually, the answer is gear lapping is an operation after heat treatment. Okay, after the heat treatment has been taken off, the gear lapping is an operation we have to carry it out. Because why? What is the need of it? We use the surface hardening process to achieve high hardness at outside surface of the gear. After that, gear lapping operation is introduced to polish and finish the external surface of the gear. The need of gear lapping is to polishing and finishing the external surface of the gear. That is the major purpose of gear lapping. Okay, gear lapping is a process of importing a fine, very fine finish, not a fine finish, very fine finish and high degree of accuracy to gear teeth. So lapping typically improves the wear property of the gear teeth. To ensure smooth and quiet running, the gear and the pinions are lapped after hardening. Lapping is accomplished by running matting pairs together in a gear lapping machine and feeding a liquid abrasive compound under pressure into a gear pair. So the compound removes small amount of metal as a gear rotates, thus refining the tooth surface and achieve desired contact action. Okay. So in order to achieve a polished and a finish of external surface of the gear, we need a gear lapping. So the answer for the gear lapping is an operation after heat treatment process. Next one. The facing is an operation of beveling the extreme end of the workpiece, embossing a diamond shaped pattern on the surface of the workpiece, reducing the diameter of the workpiece over a very narrow surface, machining the end of the workpiece to produce a flat surface square with the axial. The facing is an operation of beveling the extreme end of the workpiece, embossing a diamond shaped pattern on the surface of the workpiece, reducing the diameter of the workpiece over a very narrow surface, machining the ends of the workpiece to produce a flat surface squares with the axle. If anybody knows the answer, kindly share it. Yeah, let us we will discuss. The facing is an operation of machining the ends of the workpiece to produce a flat surface squares with the axial. Facing is an operation of machining the ends of the workpiece to produce a flat surface square with the axial. Because facing operation is done on the lathe machine by adjusting tool post angle, that is at 45-degree angle. This operation is done to get a good flat surface. It may cylindrical or square workpiece. Because of phasing, in which it is to reduce the length of the component, whereas turning is to reduce the diameter of the component. Okay, so the phasing is an operation of machining the ends of the workpiece to produce a flat surface squares with the axles. Note down the answer actually. Next question. The fixer is defined as a device which fixture. Actually, a fixture is defined as a device which hold and locate a workpiece and guide and control one or more cutting tool hold and locate a workpiece during an inspection or for a manufacturing operation is used to check the accuracy of workpiece. All the above. A fixture is defined as a device which hold and locate a workpiece and guide the control one or more cutting tool hold and locate a workpiece during an inspection or for a manufacturing operation is used to check the accuracy of the workpiece. All the above. Actually, the fixture is defined as a device which is used to hold and locate the workpiece during an inspection or for a manufacturing operation. The fixture is defined as a device which hold and locate a workpiece during an inspection or for a manufacturing operation. Okay. Why? Because the fixture is used to hold the workpiece and guide it. The purpose of fixture is used to hold the workpiece and guide. Okay, that's the main objective of the fixture. Whereas a device that does not does both the function. A fixture is a only device having the both the function, holding the work and guide it. Okay, which is a fixture, a jig, and whereas the fixture is a work holding or supporting device used in the manufacturing industries. The device that having both the operation, that is both the function, holding the work and guiding a tool is jig, whereas fixture is a work holding or supporting device used in manufacturing industries. So fixture is not used at any type of inspection. So finally, we have to decide that fixture is defined as a device which hold and locate a workpiece during an inspection or for a manufacturing operation. Next one. A drill considered as a cutting tool having zero rack is defined as a drill considered as a cutting tool having zero rack is known as flat drill, straightened fluted drill, parallel shank twist drill, tapered shank twist drill. A drill considered as a cutting tool having zero rack is known as flat drill, straightened fluted drill, parallel shank twist drill, tapered shank twist drill. Anybody knows the answer? Anybody? Actually, a drill considered as a cutting tool having zero rack is known as straightened fluted drill. Straight fluted drill. Option B is a correct one. Having a different options of flat, parallel, and tapered, but the exact answer is straight fluted drill. Why? Because straight fluted drill prevents drill from drawing itself into material while cutting. Okay. Actually, straight fluted drill prevents drill from drawing itself into material while cutting. That's why a drill considering a cutting tool having zero rack angle is called a straight fluted drill. Okay. Note on it. Note on the answers. A drill considered as a cutting tool having zero rack is known as straight fluted drill. Actually, we had to clear the subject. It is we all studied these subjects, but what is the purpose of go through these all? Or due to we had to clear the gate examination. These GATE examination score will help you for getting a good placement in tier 1 companies, and also it will be much more helpful in um, placing offers in government sectors like petroleum industries and railway industries also. So kindly get prepared well and get a good score. It will be change your future to a betterment. Can you go for the next one? Okay. Which of the following statement is wrong about ultrasonic machining? Which one of the following statement is wrong about ultrasonic machining? It is best suitable for machining hard and brittle material. It cuts material at very slow speeds. It removes large amount of material. It produces good surface finish. Which of the following statement is wrong about ultrasonic machining? It is best suitable for machining hard and brittle material. It cuts material at very slow speed. It removes large amount of material. It produces good surface finish. Okay. Can you go for the answer? Which one is wrong? Actually, best suited for machining hard and brittle material. Ultrasonic machining is best suitable for machining hard and brittle material. So first one is not right one, and it also having the material cuts at a very slow speed also. Ultrasonic machining cuts the material at very slow speed also. And third one is it produces good surface finish also. So finally had to decide that it removes large amount of material is a wrong one. Why? Because ultrasonic is a slow process, so it can't remove large amount of material. Nowadays piezo crystals are used in ultrasonic machining, so it is a slow process, so it's not possible to remove a large amount of material. It removes a very small amount of material at slow speed with good surface finish. So machining process always removes less material in not a large amount of material. So the false statement is it removes large amount of material is a wrong answer. While because the machining of material removes in ultrasonic machining is a brittle fraction. Tool material should be soft. So material removal depends on flow rate of abrasive particles and size of the abrasive. And the material removal rate is maximum in EDM and less in EBM. Okay. So the correct answer is large amount of material. It removes large amount of material is a wrong statement. No, don't answer. Next one. In oblique cutting system, the the maximum chip thickness occurs at the middle. In oblique cutting system, the maximum chip thickness occurs at the middle. Is it correct or not? Oblique cutting. Oblique cutting means inclined areas. The maximum chip thickness occurs at the middle. Is it correct or not? Actually, in oblique cutting operation, all sides the chip thickness are equal. Okay. not exactly at the middle. Actually, the chip thickness is equal throughout the all the sides. So the statement is actually incorrect. Okay. In orthogonal cutting, that is 90-degree cutting chip thickness is in middle, while in oblique it may be at anywhere. Okay. All side chip thickness equals in oblique cutting operation. There is no possibility of improving or maximizing the chip thickness at exactly at the middle. Okay. So the statement is actually wrong one. When actually oblique cutting is a type of material cutting operation in which cutting edge of the tool is straight and inclined to the direction of the tool or work travel. This helps chips to flow easily. So it is a incorrect statement. Note on it. Next one, larger edge cutting, larger end cutting edge angle having dash to life. It will increases, decreases, or there is no effect on it. What will be the correct one? Large end cutting edge angle or having dash to life. Whether it having increasing to life or it will decreases or there is no effect on it. Anyone knows? If end cutting angle increases, if the end cutting angle increases, simultaneously decreases the lip angle or wedge angle of the tool. Okay, so due to that the stress concentration, heat dissipation will decreases the tool life. So the large end cutting angle always decreases the tool life. So the option B is the correct one. Larger end cutting angle decreases the tool life. Okay. Actually, if you increases the rack angle, the force developed will be less. Simultaneously, power consumption less and tool life increases. But this is limited up to 45 degree. But with increase in rack angle, the strength of tool reduces. Experimentally, with increase in 1 degree rack angle, there is 8 to 10 percentage reduction in force. Okay. If you increase the rack angle, the force developed will be less. Simultaneously, power consumption less and tool life increases. But this is limited up to 45 degree. But with increase in rack angle, the strength of tool reduces. Experimentally, with increase in 1 degree rack angle, there is 8 to 10 percentage reduction in force. Okay, note on it. Large end cutting angles decreases the tool life. Next one, the lead screws of lathe has the lead screw of a lathe has dash threads. Single start, double start, multi start, any one of these. The lead screw of lathe has dash threads. single start, double start, multi start, any one of these. Okay, can we discuss the answer? The lead screw of the lathe has single threads. Why? Because single single start thread is one continuous thread along the body of the screw. So the lead screws of the lathe has single stud threads. Single thread heads have a one continuous thread along the body of the screw. So the lid and the pitch are equivalent single stud threads. Actually, the lid and the pitch are equivalent single stud threads. Okay. Whereas lead screws of the lathe have multi-stud threads also, but preferably the lead screws with the lead and the pitch are equal in single thread. So we have to prefer lead screws of single stud threads because it is a continuous thread along the body of the screw. Okay. Have you noted? Next one. A left hand tool on a lathe cuts most efficiently when it travels. A left hand tool on a lathe cuts most effectively when it travels from left to right end of lathe bed, from left to left end, from right to left end of the lathe bed with the help of compound slide across the bed. A left hand tool on a lathe cuts most effectively when it travels from left to right end of the lathe bit, from right to left end of lathe bit with the help of compound slide across the bit. Which one is the correct answer? The left hand tool on the lathe cuts most effectively when it travels from left to right end of the lathe bit. Actually, that's the correct answer. From left to right end. It is the common procedure. For the most efficient way, we have to travel from left to right end of the lathe bit. Why? Because single point tools have mainly two according directions to move from left hand from right hand. Left hand tools to cut from left to right, right hand tools from right to left. So the preferred travel for efficient way in lathe is from left to right end of the lathe bed. Noted. Make it fast. Next one. The correct sequence of tool materials in increasing order of their ability to retain their hot hardness. Kindly understand the question clearly. Hot hardness. The correct sequence of tool material in increasing order of their ability to retain their hot hardness is carbide, ceramic, cement, borasan, ceramic, carbide, borasan, cermet, cermet, carbide, ceramic, borasan, boron, ceramic, carbide, cement. The correct sequence of the tool material in increasing order of their ability to retain their hardness. The important keys here is hardness. Okay, hardness is carbide, ceramic, cement, boron, ceramic, carbide, boron, cement, cement, carbide, ceramic, boron, ceramic, carbide, and cement. Which one? Which one is the correct one? Any guesses? Actually, mm, the cement is a new material to know you that cement is a combination of ceramic and metal, and boron is a combination of boron and atoms of nitrogen. Okay, this is the two new materials you may hear right now. Cement is combination of ceramic and metal, and whereas boron is a combination of boron and atoms of nitrogen. In cement, 90% ceramics and 10% of metal mixture. Whereas boson is nothing but a boron nitrate. Okay. Hardness temperature is the maximum temperature up to which it can absorb without deformation. That is hardness. Hardness temperature is the maximum temperature up to which it can absorb without deformation. It is the ability of the material to retain hardness at high temperature. Okay. So the order is cement, carbide, ceramic, and boron. The correct sequence for hardness in increasing order of tool material, which is cement, carbide, ceramic, and boron, in which boron is a combination of boron and atoms of nitrogen, that is boron nitrate, whereas cement is a combination of ceramic and metals. 90% is ceramics and 10% of metal mixtures. Have you noted? Have you all noted? The next one. The cutting tool in a milling machine is mounted on. The cutting tool in a milling machine is mounted on spindle, arbor, column, knee. The cutting tool in a milling machine is mounted on spindle, arbor, column, knee. Which one is the correct one? Think and tell. The cutting tool in a milling machine is mounted on. Actually, it is mounted on arbor. Arbor means nothing but a type of machine element. It is below the spindle. Tool is mounted in that place. It is it is maximum placed in a horizontal milling machines. Okay. Arbor is a device which is used to fasten the spindle by attaching, and the milling cutter is mounted on it. So the cutting tool in a milling machine is mounted on arbor. Okay. Maximally, this type the tool be attached with arbor and worm gear in order to connect the spindle also. I will note it. Next one. The tool made of cemented carbide wear out faster at the tool made of cemented carbide wear out faster at slow speeds, medium speeds, fast speed, very fast speeds. The tool made of cemented carbide wear out faster at slow speeds, medium speeds, fast speeds, very fast speeds. Any idea? The tool made of cemented wear out faster at slow speeds. Okay, at very slow speeds because of availability for wearing. That is the main reason actually. Because in powder metallurgy techniques, the cobalt binder uh, is that the temperature is very high, so that cemented carbide tools are used for machining stainless steels, carbon steels, which are very hard. Cemented carbide tools are used for machining stainless stainless steels, carbon steels, which are very hard. In slow speed, the contact between the surface are more, so it is obvious that at low speed it will wear more. Mm, as well, the friction will be less at high speed also. So that's why we tell powder metallurgy technique. The slow cutting, the heat generation is too high, so metal remove rate also very high. So the correct one is the tool made of cemented carbide wear out faster at slow speeds. Okay, that's the exact answer. And I want to suggest one thing that carbon tool is used for high to very high speed accuracy machining. Actually, carbide tool is used for high to very high speed accuracy machining. So it wears out at very low speed only. So low speed is um, um, out of very um, narrowing of carbide tools. So it wears out at a low speed only, not at a fast speed. Kindly make a note on it what we are discussing right now, because in future it may help you for preparing your examinations. Next one. Twist drills are made of. Twist drills are made of high speed steel, carbon steel, stainless steel, either A or B. Twist drills are made of. Twist drills are made of high speed steel, carbon steel, stainless steel, either A or B. Which one is the correct one? Anybody knows the answer? Actually, um, wait 1 minute. Yeah, actually, twist drills are made of high speed steels, or carbon steels or stainless steel? Or the last one? Actually, the answer is either A or B. Okay, either A or B. Twisted drills are those have threaded shape and rotates with high speed when drilling. So materials high speed steel and carbon steel which are used because of high strength and high speed. Okay, that's the main purpose. Because of stainless hardness is low because of low carbon content, and also it is ductile in nature. So twisted drills is made of high speed steels with the carbon steels. So the answer for twisted drills are made of either A or B, high carbon or carbon steels. Noted. The rack angle required to machine brass by high speed steel tool is. The rack angle required to machine brass by high speed steel rule is 0 degree, 10 degree, 20 or minus 10 degree. The rack angle required to machine brass by high speed steel tool is 0 degree, 10 degree, 20 or minus 10 degree. Actually, bronze is soft material. Okay, bronze is a soft material. Due to this, using high speed with a zero rack angle is preferred. Okay, so the answer is zero. Good surface is also obtained with the zero rack angle while machining bronze with the HSS tools. So we have to prefer 0 degree rack angle. For brittle materials, negative rack angle required. For ductile materials, positive rack angle required for machining brass is between the above two material. For brass, we have to use a zero rack angle. The rack angle may be a positive or negative. For brittle, we have to need a negative rack angle. For ductile, we have to use a positive rack angle. If the rack angle is zero, then there will be excess tool wear also. That we have to consider. But anyhow, we have to keep 0 degree rack angle for the brass machining at high speed steel tools. Have you all noted? Kindly note what are the things I have to discuss during this class, because after some more time you have to go through. You may know the answer, but what is the reason behind this answer? You have to kindly note what we are discussing right now. Okay. Next one. The lip angle of single point tool is usually the lip angle of single point tool is usually 20 to 40 degree, 40 degree to 60 degree, 60 degree to 80 degree, none of this. The lip angle of single point tool. The lip angle of single point tool 20 to 40, 40 to 60, 60 to 80, none of this. Which one? You all know what is lip angle? Actually, lip angle is also known as wedge angle. It is the angle between a rack angle and the clearance angle. It is the angle between rack angle and clearance angle. If the lip angle is high, that means strength of the tool is also high. So The lip angle of the single point cutting tool is usually 60 to 80 degrees. Usually it is between 60 to 80 degrees. Between rack angle and the clearance angle. Larger the lip angle, higher the strength of the tool also. Larger the lip angle, higher the strength of the tool too. So lip angle, how to calculate the lip angle is equal to 90 minus back rack angle minus clearance angle. Or else you have to calculate by 90 minus back rack angle plus end clearance angle. We have to calculate the lip angle by means of 90 minus back rack angle minus clearance angle, or 90 minus back rack angle plus end clearance angle. Anyhow, I have to calculate the lip angles. Next one, the average cutting speed for turning brass with a high speed steel tool. The average cutting speed for turning brass with high speed steel tool is 15 to 19 meters per minute, 25 to 31 meter per minute, 60 to 90 meter per minute, 90 to 120 meter per minute. The average cutting speed of turning brass with a high speed steel tool is, actually the answer is C, 60 to 90. Actually for brass is 30 to 60. There is no option for 30 to 60. Actually the brass is preferring for 30 to 60 degrees, whereas cemented carbide is 60 to 200. Cemented carbide is for 60 to 200, and for 25 to 30 for possible tool velocity is for standard brass speed. Bronze and brass are, bronze and brass is 60 to 90. For mild steel 20 to 45. For copper 18 to 30, and stainless steel 12 to 18. Okay, for brass is 60 to 90. Brass, aluminum, brass, and bronze. Aluminum, bronze, and brass. All the material having a cutting speed of 60 to 90. And I note down quick. Next one. The maximum protection of small and slender parts is done by. The maximum protection of small and slender parts is done by watchmaker's lathe, sliding headstock automatic lathe, multi-spindle automatic lathe, caption lathe. The maximum protection of small and slender parts is done by watchmaker's lathe, sliding headstock automatic lathe, multi-spindle automatic lathe, whereas caption lathe. Actually, multi-spindle automatic lathe can produce a maximum production of small and slender parts, especially or specifically for small and slender parts. We have to use a multi-spindle automatic lathe. Why? Because slender parts consist of different types of operations, so it must need a multi-spindle type automatic lathe. So it will create maximum production for small and slender parts. multi-spindle automatic lathes working with the different types of operations in one setting of job. Actually, in one setting of job, it can carry out with the different types of operations in a multi-spindle automatic lathe. Okay, it is actually same like a Swiss type automatic lathe also. Have all noted? Maximum production of small and slender parts is done by multi-spindle automatic lathe. Next one. The method of grinding used to produce a straight or tapered surface on a workpiece. The method of grinding used to produce a straight or tapered surface on a workpiece is internal cylindrical grinding, form grinding, external cylindrical grinding, surface grinding. The method of grinding used to produce a straight or tapered surface on a workpiece is internal cylindrical grinding, form grinding, external cylindrical grinding, surface grinding. If anybody knows the answer, or else I will discuss it. Method of grinding used to produce a straight or tapered surface of workpiece is actually the external cylindrical grinding. Why? Because external cylindrical grinding is used to grind cylindrically. Okay, it will specifically for external surfaces. Surface grinding uses rotating abrasives wheels to remove materials, creating a flat surface. So surface grinding is not suitable. So external cylindrical grinding is preferred for these operations. Okay. Actually, both internal and external cylindrical grinding is used to produce straight or tapered surface. But as it is mentioned in that question that the straight and tapered grinding is to produce on the workpiece, external cylindrical grinding is exactly the correct one. Okay. So the right one is external cylindrical grinding, not surface grinding. If anybody knows the form grinding, actually form grinding is a specialized type of centralist grinding where the grinding wheels is at the exact shape of the fine product. Okay, fine form grinding is a specialized type of centralist grinding where the grinding wheel is the exact shape of the final product. All noted, right? Okay, fine. Yeah, thank you all for your patient listening. I think everybody get a little bit knowledge regarding this manufacturing technology process. We will see in the next class. Okay. Thank you. Thank you all.